Question 8. Octane and isooctane are structural isomers with molecular formula C8H18. Displayed formulas and boiling points of octane and isooctane are shown in figure 2. You can clearly see that octane has a higher boiling point than isooctane. Not incredibly, not extremely significant, only 26 degrees Celsius, but it's still pretty high. Give that a UPAC name for isooctane. So we have got, we're going to start from the left hand side, so it's going to be 2, and we've got 1, 2, so 2, 2, and then 1, 2, 3, 4 methyl, so it's going to be 2, 2, 4, 2, 2, 4 dash trimethyl, and what's the longest carbon chain? 1, 2, 3, 4, 5, methane, ethane, propane, butane, pentane, pentane. 2, 2, 4 trimethyl pentane. Then it says enable laboratory technique to separate isooctane from mixture of octane and isooctane. It can be fractional, or you could say simple distillation, fractional distillation. And like I said, isooctane has a lower boiling point. So isooctane has a lower boiling point, hence it will reaches top of the column first, and therefore isooctane condenses, liquefies, and collected away from the octane, and therefore this technique can clearly show how we separate isooctane from octane. Write an equation for complete combustion of isooctane using molecular formula this in your equation. So C8H18. So when it's complete combustion, we've got more than enough oxygen and we form carbon dioxide and water. So we've got 8 carbons on the left hand side, so we're going to have 8 here. 18 hydrogens on the left hand side, we're going to have a 9 here. Now how many oxygens do we have on the right hand side? 16 plus 9, what's that? That's 25, so therefore we're going to have to have 12.5, 12.5 over 2 on this side. Explain how catalyst works. Catalyst works provides alternative pathway with a lower activation energy. So the 2 key points: alternative pathway, lower activation energy. Carbon dioxide produced when incomplete combustion, nitrogen monoxide, another pollutant, produce collagen. Write an equation how the pollutant react together, catalytic converter. So we've got 2CO plus 2NO to form N2 plus 2CO2. And the thing about equations is the AQA exam board, they could choose any equation from year 1, because obviously this is an AS level paper, and you'd be expected to know it off by heart. Or they could choose an equation and then give a couple of other follow-up marks, like another 1 mark saying what's the role of this? Is it oxidizing agent? Is it reducing agent? For those type of questions. So you do need to know all the equations. Obviously, some equations occur more often than others, like reduction of titanium chloride, phosphorus with oxygen form phosphorus oxide. However, other equations can come up, and if you haven't learned them, then you're going to lose at least a mark, or maybe more, maybe 3, 4, 5, depending on how many times the different equations come up. So please learn your equations. And then 3.6, platinum, palladium, and rhodium are metals used inside catalytic converters. Explain why a thin layer is used in this way. Thin layer is used because it reduces to reduce amount of metals needed to reduce amount of metals needed, and therefore increase surface area. Or we could say larger surface area to volume ratio in the catalyst. So reduce amount of metals needed, increase surface area, or larger surface area to volume ratio. 3.7. Bit of information here, but it says identify region show oleic acid is unsaturated. It's going to be bromine, Br2, and the observation is going to go from orange to colourless. And that is the end of question 3.